homework 1, now we're going to solve these systems equations using the elimination method and then the substitution method. So in the first one, we're going to multiply this second equation. If we start off using the elimination method, we're going to multiply this second equation by minus 2. So minus 2x plus 2y is equal to minus 2. The reason why we do that then is so that we can now simply add these two equations together, the first and the second, and we end up with 5y is equal to 35, y is equal to 7. If y is equal to 7, we're going to substitute this y value into either of those equations. So let's take the simplest one. Y equals 7, x minus 7 equals 1, so x is going to be equal to 8. And there we go. Our solution set is then x equals 8, y equals 7. If we rub that out then, and then use the substitution method, so we're going to write one variable in terms of the other. So the simplest one to use would be this down the bottom, so that x is equal to y plus 1. And then we're going to substitute that in to the other equation. So 2x would be the same as 2y plus 1 plus 3y is equal to 37. We've now got 2y plus 2 plus 3y equals 37. 5y subtracted 2 is 35. Y equals 7. And we're at the same place. We found y equals 7, we substituted back in here, and we found that x is equal to 8. On to b then. And so there's a couple of ways we could do b. The way I'm going to choose then is I use the elimination method. Is I want my x's to have the same coefficient. So I've got x divided by 3 and x divided by 4. So what I'm going to do is I'm going to cancel out the denominator in both cases. So in the first case I'm going to multiply everything by 3. So I get x plus 3y over 2 equals 3. And in the second equation I'm going to multiply everything by 4. So x over 4 becomes x minus 4 over 3y equals 4. And now, if I subtract the second equation from the first equation, I get 0 here, and then I get 3y over 2 minus minus, so plus 4 3 over y equals minus 1. And then now if I want to simplify this, I can multiply everything by 6. So let's multiply like this. And what do we end up with? 9y plus 8y is equal to negative 6. And so we get 17y is equal to negative 6. Y equals negative 6 over 17. Then we're going to substitute that back in to one of these equations. Just take the first one, x over 3 plus minus 6 over 17 divided by 2. Just the same as multiplying by 1 over 2 is equal to 1. And so x over 3 is equal to, subtract 6 over 34 is equal to 1. Add that 6 over 34 to the other side. So we're going to have 34 over 34, which is 1, plus 6 over 34. So we're going to end up with 40 over 34 is equal to x over 3. Got more space, and so x is going to be equal to 120 over 34, and if we cancel that down, it comes to 60 over 17. So my solution set is 60 over 17, should be a comma, minus 6 over 17. Now if we start again then and use the substitution method, we should also say that this elimination method isn't the only way of solving this. We could have multiplied both equations, could have multiplied this equation by 6, both sides, and then this equation by 12, and then work from there. But anyway, if we're going to use the substitution method, I'll use the bottom equation and say x over 4 is now equal to 1 plus y over 3, and x is equal to, then if we multiply everything by 4, 4 plus 4y over 3. And then we're going to substitute that in to the first equation. So instead of x, we've now got 4 plus 4y over 3 divided by 3, so all times by 1 over 3 plus y over 2 is equal to 1. And if you expand this bracket then, 4 over 3 plus 4 over 9y plus y over 2 is equal to 1. Subtract then the 4 over 3, minus 4 over 3, and then add together 4 over 9 plus 4 over 9y plus y over 2. So if we give them both a common denominator, so 18, we're going to have 8 over 18y plus 9y over 18. And then if we simplify that, we've then got 17 over 18y equals negative 1 over 3. And then rearranging, we're going to get y is equal to negative 6 over 17. And then again we substitute this value back into one of those equations and find x. I'm going to rub this out again. In C for the elimination method, then we're going to rearrange one of these equations to make it easier. So I'm going to rearrange the second equation so that we've got x and y both on the same side. So I'm going to end up with minus 4x plus 2y is equal to 6 if I subtract 4x from both sides. And then if I write in the remaining equation, I end up with this. And then I'll multiply this bottom equation by 2. So let's call this 4x minus 2y equals 8. And then if we add those two equations together, we're going to get 0 plus 0 is equal to 14. So what does that tell us? Well, that tells us that no values of x or y are going to satisfy these two equations. That means that we've got the empty set. If we then use the substitution method just to confirm that, so I'm going to take the first equation, 2x minus y equals 4, add y to both sides, and then divide by 2, 2 plus y over 2, and then I'm going to substitute that into the other equation, so 2y is equal to 4 times x, or in this case 2 plus y over 2, plus 6, so 2y is equal to 8 plus 4 over 2y, so 2y plus 6. And then again you can see if we cancel out these two y's, 0 is equal to 14, which is not true, which means that no values of x and y will satisfy these two equations. If we move on to D then, I'm going to use the elimination method first. I'm going to multiply the first equation by negative 2, which gives me minus 8, plus 2b equals negative 10. And then if I write in the other equation below, minus 2b equals 10. I'm going to add these together, so I get 0 plus 0 is equal to 0. So what's this telling me? This tells me that this is true for all values of a and b. Why is that true? Well, it's because, and we'll get into this, or you should notice, is that both of these equations are actually the same line. They're coincident lines. If we use the substitution method then, over here, we can say that a is equal to 10 plus 2b, and then if we substitute that in to the first equation, half a, or 10 plus 2b, minus b is equal to 5. So we get 5 plus b minus b is equal to 5. 0 is equal to 0. So again, this is true for all values of a and b, and therefore we've got infinitely many solutions.